If you're wondering when we're going to get to doing some hands-on stuff, it's just another chapter or so, we're talking about hypervisors. You can go ahead and download the Oracle hypervisor, what they call the box, the virtual box. You can download different virtual operating systems and things like that. So we can do that, but today we're going to talk about what's in chapter 2. All right, describing a hypervisor. What's a hypervisor? Oracle, the Oracle VirtualBox is a hypervisor. Okay, it is a software, or it's a software that allows you to have several machines. Okay, if you ever did this before, you can use the hypervisor. You can have an Ubuntu machine. You can have several different types of other machines built in the computer. All right, so here we go. So here's a diagram. Hypervisors manage the interactions between all virtual machines and that are guests to share. So here's the hardware. That represents the PC, the motherboard, the hard drive, the RAM, the network interface card, all the hardware. This is the hypervisor, and this is a virtual machine. It runs, and we can have several of these virtual machines that the hypervisor is going to manage. Okay? It's a cute little diagram. All right. So exploring the history of hypervisors. This used to work a lot with the virtualization and IBM on IBM computers. And IBMs are the ones that made the mainframes, the big computers for international business machines. They're still around. I think Lenovo bought them. This is the first virtual machine monitors were used for development of debugging operating systems. Sandbox is a big word in the IT, our playground, sandbox. So it's a place where you can experiment with different types of operating systems, different types of scenarios, and it doesn't end up ruining a machine. You can just start all over again. All right, so here we go. The structure of VM is fairly simple. It consists of a layer of software that lives between the hardware host and the virtual machines. Okay, it's just another one. So here's a guest operating system, the virtual machine, and the virtual machine monitor or hypervisor, and the physical server host. Now we're going to talk about the two types of hypervisors. Okay, type 1 hypervisor is one that does not have an operating system. That's a main thing, is that there's not an operating system sandwiched in between the hardware, the physical server, and there's no operating system here. We're going to see another. You're going to see the diagram. This is a type 1 hypervisor. Okay, right here. Type 1 hypervisor, the guest operating system, and the virtual machine that runs with the guest operating system. The guest operating system is running on the hypervisor. All right. Type 1 and 2 hypervisors, so understand the hypervisors. Type 1 runs directly, I just said that, runs directly on the server. Some people call it a bare bones hypervisor or bare metal implementation. And bare metal is another thing they call it, a bare metal. Okay? And so this is the physical server. So you just saw that diagram again. All right. One cool thing about the virtual machines is, again, I love this cafeteria plate things. If you're a person who does not like your food to touch, right? My food touch. Okay. This is a good plate for you. That way the dessert and the orange and it looks like an egg. I think it's an egg. Doesn't touch, right? The virtual machine getting damaged only itself. It doesn't cause any problems. That's a beautiful thing about the virtual machine. If I have several virtual machines and I'm over inside another virtual machine and I try some kind of experimentation and it fails, it's only going to lock that one thing up. It's going to keep everything running just fine. So we're completely isolated, and that's good for security. And because one thing about security is people like to try to jump over, okay, from the hypervisor or to the operating system. If you ever take a server class, you'll see that we'll put the operating system on the C drive and a lot of the data on the D drive on another partition. That way, we're giving people access to our data, but not necessarily to the drive that has the operating system on it, because that creates a vulnerability. So keeping things separated and keeping things separated is definitely a security asset. All right. Here's another diagram of it, so in case you haven't got it. Less processing over head is required for Type 1 hypervisor. Why? Because we don't have an operating system. So a Type 1 hypervisor doesn't have an operating system to contend with. So virtual machine, we have several virtual machines right here, and more virtual machines can be run at each host. So if we're using a Type 1 hypervisor, we don't have an operating system, and we definitely less resources, because if we're running Windows 10, like we're going to do a lot with the Oracle box, we're going to be running that on Windows 10. So Windows 10 has its own demands on your computer. And then we run the Oracle box, which has more demands on your computer. Okay, here we go. This is a Type 2 hypervisor. In the red, we'll see that this is the operating system. All right, the physical layer of the operating system in the Type 2 hypervisor, like the Oracle box, is now running Guest OS and C, and that's why it runs a traditional operating system. Okay, Windows 10. This is Windows 10 right here. Okay. Understanding the role of a hypervisor, it provides an environment identical to the physical environment. A lot of this virtual things we're doing, even in computer networking, we're doing a lot of virtual things. And I say that we, the humans, know that we've created a virtual device or a virtual appliance or a virtual machine, but the machines don't know. And so they think, and everything looks like a real machine to the machines. We as humans know. We've tricked the machines. Plenty enough tricking, the machines tricking the humans. Now we kind of have a reverse thing going on. Provide an environment with a minimum performance cost. Okay, so the hypervisor is, provides the environment with lower performance cost and retain complete control of the system resources. Okay, so it's actually quite a stunt to install several virtual machines on one machine. Because you have to create a virtual network interface card. And I have this computer right here, and if I IP config this computer that I'm using right now, I have several virtual Ethernet adapters because I've been doing a lot of these virtual machines on here. So I have a lot of virtual NICs, and it looks like it looks like real network cards, but you only have one network card in this machine. So this is a Type 1 hypervisor. We'll mostly Type 1 hypervisors are expensive. Like I said, Oracle lets you have it for free. Lets you play with it for free. So anyway, stay tuned for some chapter. I don't know why it froze up on me. Okay, it froze up on me. I'm sorry. So here's another diagram that kind of explains how a hypervisor works. And so we're breaking down the hardware. Here's a processor, here's some RAM, here's a network interface card, and here's a hard drive. And so we have an application, an operating system, and a virtual machine. We have two virtual machines running on top of a hypervisor. Okay? And so it's just each guest makes a constant demands on the various resource subsystems. In a way, hypervisor acts like a traffic cop controlling the flow of vehicles. So a lot of ways is what the hypervisor, what it's doing is it's allocating resources and allowing different machines to run and without allowing any one machine to completely take over the machine and cause the system crash. So it is acting like a traffic cop. It is a kind of interesting thing. It's quite a feat, like I said before. All right. So compared to today's hypervisors, we're not going to go into a lot of this deep depth, but it's in the book if you want to read about it. There's Oracle, Solaris Zones, BSD jails, and FreeBSD, HP containers, and PowerVM, and IBM, and AIX. So there's just to name a few of the brand names. VMware was the first one. I'm going to talk about that briefly. It was founded in 1998. Its market share is not always the best indicator of the solution's viability. I like that the book did say that. But I believe at the time the book was written, VMware held 70% of the market share for virtual machines. Market share is not always the best indicator of the solution's viability. you may not ever get to hear my big speech about Microsoft. Microsoft never provided the best solution. It just became it just took over. Okay. There was actually a Novell NetWare that was and had GroupWise, which was a better email system than than Outlook or Microsoft Exchange. They even use a protocol called IPX that was supposed to be faster and more secure than TCP/IP. And you want to talk to your parents about Betamax versus VHS. A lot of those standards weren't really the best, and I do like that. It's a very smart thing to say in a technology conversation. Market share is not always the best indicator of solutions viability. And here is a diagram of what Microsoft Hyper-V looks like. Hyper-V is type 1 hypervisor, and it's probably going to take over the world, just like everything Microsoft does. Let me get back here and let you look at the diagram. The child partition, a parent partition. They have a VM bus, they have the hardware, which is the server, the motherboard, the hypervisor, and we have these virtual machine, the VM buses. So this is kind of how it looks like, how it all looks like. There's plenty of YouTubes on there and plenty of information on the net if you like a particular favorite hypervisor that you want to look at. Coming soon, we're going to be using the Oracle. All right, this is chapter 2. Thank you.